Hi friends, ఈరోజు మనం going to know about impulse turbine velocity diagram. Impulse turbine velocity diagram. And now here I consider one vane or blade. Okay, now I consider one vane or blade. This is for blade velocity A to B. Okay, now this is here I put inlet. Okay, now and the absolute flow velocity, now absolute flow velocity, it will act like this. This is V1. And now here to here you can join this triangle, you will get VR1 relative velocity. Here the angle we don't know, that I put it alpha 1. Okay, and draw one horizontal line. Similarly draw one vertical line. This is the point. Okay, A, B. Now I take this is C, this is D. Here I have one angle, so I put it here beta 1. So here I write down alpha, I take here absolute velocity angle. Then beta I take for blade angle. Okay, now look at this diagram. In here this is absolute velocity angle. Okay, now this angle is coming from blade angle. Okay, now we go for exist. Now then here exist, similarly I draw same thing, blade velocity A. Now this is A and now this is B. Why? Because here the relative velocity, now flow velocity, absolute flow velocity, it will come and here it will going like this. Now this is V2. Okay, so now here look at this in exist. Okay, in exist here consider one velocity clearly, and the flow velocity it will come with blade velocity going like this. Okay, so I put this point. Now here I join these two. So now this is called real velocity. Okay, VR2, right? Okay, now then here to here, this is from VW1. Okay, this is from VW1 and now this is U. Similarly here also we are going to draw one horizontal, one vertical line. Instantaneously it will touch in here. So this is called for flow velocity, and this is also flow velocity V1, sorry, VF1, VF2. And then to here, this is U, and this one is coming from here to here, VW1. Okay, look at this, here to here, VW1, and now this is U. Okay, this is the velocity diagram of impulse turbine. Now we are going to solve the problems. We have combined these two velocities, inlet velocity and outlet velocity. How we will draw it combined of two velocities. Okay, now commonly I take here blade velocity U, A, B. Okay, so now here we take A, B. This is A, this is B velocity U. Okay, now come to the point here, B to C, that is coming from here, V1. So as T is, you can draw in here. Okay, you don't know that angle, so you draw. This is coming from V1. What is the angle in here? Alpha 1. And similarly here also we are going to put, this is for blade velocity beta 2, and this is for alpha 2, absolute velocity alpha 2. Okay, and then here we draw this one, and next vril velocity is there. C to A is vril velocity. Now join this point is C. VR1. Okay, vril velocity. And then similarly we are draw this and this. I put here the point is called D, A, B, C, D. Now this is the angle is given in here, beta 1. Okay, so this is the outlet velocity diagram. For go to the inlet velocity diagram, as it is we can draw, and look at this A2 dash VR2. Now you can draw this VR2 directly. It will going like this, VR2. This is like, I will draw like this. Okay, and now what is the angle in here? Beta 2 is the angle between this vril velocity and blade velocity. And now we are going to draw here velocity. So it will come to point B, and vril velocity is there, so can touch this thing. Straightly draw this line, so it will come here V2. Then similarly we are going to draw one vertical line and one horizontal line. Okay, then this angle is coming from here alpha 2. Look at this, this is alpha 2 in hidden lines alpha 2. Okay, now this is coming from VF2 and this is coming from VF1. And then, and look at here, this point B to this point D, the distance is called VW1. Okay, the distance is called VW1. And now then here to here, So I'm going to draw this VW1, and then D you can fix here E, and this is coming from F. Okay, so similarly here we are going to fix the points in here. This is for E and this is for F. Okay, now look at this. This is point B. Point A to B is blade velocity, and then B to F is real velocity 2. Okay, so B to F is real velocity 2. So now we are going to here, B to F is there. So now this is real velocity 2. So totally this length is coming from change in real velocity. Okay, this total length is called from change in real velocity. So this is the velocity diagram to draw the impulse turbine. Okay, అయితే ఇక్కడ ఈ డయాగ్రామ్ గీయటం అనేది చాలా ఇంపార్టెంట్ థింగ్. ఈ డయాగ్రామ్ గీయటం వచ్చిందంటే మన ప్రాబ్లమ్స్ అనేవి ఈజీగా సాల్వ్ చేయొచ్చు. ఓకే, ఈ ప్రాబ్లంను బట్టి వెలాసిటీ డయాగ్రామ్ యాజ్ ఇట్ ఈజ్ ఇలాగే ఉంటుందని నేను చెప్పలేను. సమ్ టైమ్స్ ఏంటంటే ప్రాబ్లంని బట్టి ఇవి చేంజ్ అవుతూ ఉంటాయి. అంటే ఇక్కడ హియర్ వీ కెన్ చేంజ్ V2 ఈజ్ ఈక్వల్ టు VF2 అవ్వచ్చు, లేదా VR1 ఈజ్ ఈక్వల్ టు VF1 అని ఇవ్వచ్చు. సో ప్రాబ్లం అండర్స్టాండ్ చేసుకొని జాగ్రత్తగా ఈ డయాగ్రామ్ కనుక గీయగలిగితే మనకి ఇక్కడ ఏవైతే అన్నౌన్స్ ఉన్నాయో వెలాసిటీస్ అట్ ది సేమ్ టైమ్ యాంగిల్స్ వీ కెన్ ఫైండ్ అవుట్ ఈజీలీ. Okay, you can find easily. So now here I am going to write all those terms in. Okay, in these terms VF1, what is VF1 and what is VW1 and what is VR1. Okay, now I am going to write these terms in here. So now first here we put here V1 and V2 is equal to inlet and outlet absolute velocity. Okay, so and now here come to this point V1 V2. So V1 and V2 is absolute velocities. Look at this. This is absolute velocity. It will come the absolute velocity with the help of blade velocity. It will going like this, V1 and V2. And next we go to VR1. VR1 and VR2 is equal to inlet and outlet relative velocity. Okay, now this is the point here I can write down velocity relative to the rotor blades. Okay, now U is equal to, this is for mean blade velocity. So U is equal to mean blade velocity. And now we go for alpha 1 is nozzle angle, and then alpha 2 is absolute fluid angle at outlet. Okay, and remaining we have it is to be mentioned that all angles are with respect to the tangential velocity in the direction of u. In the direction of u, it is to be mentioned that all angles are with respect to the tangential velocity in the direction of u. Look at this tangential velocities, okay, with the direction of u. Now this is u. Okay, now we go for here beta 1, okay, and beta 2, that is equal to inlet and outlet, okay, of blade angles. Okay, so you would circle beta 1 beta 2 circle manaki inlet and outlet of blade angles, and then we go for write down here VW1 and VW2. Tangential or will component of absolute velocity at inlet and outlet. Okay, this is the VW1 and VW2, and then we go for write down here VF1 and VF2. There is another term in here, VF1 and VF2. So it is axial component of velocity at inlet and outlet. Okay, so these all are the coming from our velocity diagram denotes. Okay, right, so this is the diagram for velocity diagram for impulse turbine. So again I told ee diagram ostene manam problems solve cheyaгаlam. So look at once here, very simple thing, AB is the blade velocity and V1 is the absolute flow velocity, and now this the combination of VR1 V1 and U, this triangle it will come with angle of alpha 1. So U VR1 V1, so angle of alpha 1, so take same thing. Okay, and now here we draw the one vertical and one horizontal, we instantaneously it will come VF1, that is called flow velocity, and again here is beta 1 is the blade angle. Okay, this is the first velocity diagram for this, and again second diagram is, look at here second diagram, this is the real velocity flow of VR2, this is coming from VR2, so I draw as easily VR2 in downwards position. Okay, like this, and again here to B to E. So I join here B to E. The point is here downward direction, like I would turn down one direction as it is downward direction here also. That is called in here V2. Now I put in here V2. And now go to this horizontal and vertical. Instantaneously here the point is come. So here vertical portion is coming from VF2 and horizontal portion it will come VW2. It's called visual velocity at outlet. This flow velocity of outlet. And now here the coming to the point here A D to B. D to B is the distance is visual velocity 1. B to F is visual velocity 2. Like that, D to B visual velocity VW1 and B to F visual velocity of outlet. Okay, right? This is the diagram. Okay, so this concept you must remember. Okay, na? Thank you. So okay, 1 minute, and now tomorrow we will discuss about how to find efficiency, power, and all those things with the help of this diagram. Okay, thank you.